Did you know that every minute more than 10,000 muons pass through our bodies?
And I think muons, they are in the electron family, but they're like, I guess the title's kind of related. They're like supercharged or something.
By cosmic rays.
I'm not 100% sure.
Hello, and welcome to
Muons
Hard
like
Science Explained, where we decode fascinating topics in science.
Massless
Today
energy.
we're going to dive into the world of muons, tiny particles that are essential to understanding some of the most intriguing concepts in physics. So, what are muons? Muons are elementary particles that belong to a group called leptons, which are subatomic particles that can't be broken down any further. You can think of leptons as tiny building blocks that make up the universe. Now, muons are quite similar to electrons.
I'm not saying that they're wrong, but they're most likely wrong with muons and electrons and all them, like quarks. They can't be broken down anymore. We were saying this like 100 years ago, that the atom, the regular like proton was the smallest building blocks. We even call it the atom. Atom stands for like indivisible or something like that, right? Where you can't be broken down any further. I'm saying that with the muons and quarks and all that, they could be broken down more, but we can't measure them because we're in the massive relative to us. They're micro quantum. They're quantum to us. But if we had something that was quantum, like around their size and measure them smaller than that, you get what I'm saying? I feel like I'm talking on my ass.
But they have a much greater mass. In fact,
harder to measure.
Muons have a mass that is about 207 times greater than that of an electron.
Okay.
This makes muons one of the heaviest elementary particles that we know of. You can think of muons as the larger version of electrons because they are so similar. Due to their size, muons have many unique and fascinating properties. One of these properties is that muons are unstable particles, which means that they decay into other particles relatively quickly. The average lifetime of a muon...
Isn't that kind of... okay, I'm not going to pause it too much, but isn't that a contradiction of what he just said? That the elemental particles, they can't be breaking down anymore, but they decay, so they break down the other... Okay.
...is only 2.2 microseconds. That's less than the blink of an eye. However, compared to other exotic subatomic particles, muons have a relatively long lifespan. In fact, muons from the sun can even reach the particle detectors on the Earth's surface. This is due to time dilation, a topic which we will get to later on the channel. When muons decay, they typically produce at least 3 particles, including an electron and 2 types of neutrinos.
Oh, neutrinos too.
Neutrinos are also elementary particles that do not have an electric charge and can pass through matter almost undisturbed. Please check out our video on neutrinos on our channel if you would like to know more. Like electrons, muons have an electric charge of -1 and a spin of 1/2. This makes them easy to study using magnetic fields, which can be used to observe their movement and interaction with other particles. One of the most exciting things about muons is their ability to penetrate matter. As stated earlier, more than 10,000 muons pass through our bodies every minute.
In retrospect, they're not really passing through matter, and the fact that matter, an atom is majority 99.998 percent of empty space, so they can pass
This rate
through.
of natural background radiation increases at higher elevations. This is because higher elevations are closer to the source of these muons from the sun. Because they are heavier than electrons, they are less affected by electromagnetic fields and can travel further before losing their energy. This makes them useful for a variety of applications, including the study of the Earth's magnetic field and the detection of hidden structures in archaeological sites. For example, scientists are using muons to study the ancient pyramids of Egypt, and they are also using muons to detect dangerous nuclear material in damaged nuclear plants. Today,
Okay, how
muons
they
are
doing
being
that,
studied in a variety of experiments all over the world. From the Large Hadron Collider in Switzerland to the Muon G2 experiment at Fermilab in the United States, scientists are working to unlock the secrets of these fascinating particles. Fermilab is home to a 50-foot diameter ring of powerful magnets which contain muons. They are created under controlled conditions by smashing a beam of protons from a particle accelerator into a target of mostly nickel. This process produces unstable composite particles called pions, which then decay into neutrinos and muons through weak force effects.
Okay.
That's all for today's episode of Hard Science Explained. Thank you for joining us, and make sure to subscribe to our channel and hit the notification bell so you never miss an episode. But what do you think? Given the unique properties of muons, such as their ability to penetrate deeper into matter than electrons, what potential applications do you think muons could have in various fields of science and technology? Please let us know in the comments section. Until next time, keep exploring the wonders of science.
I feel like the Hadron Collider is kind of like, I get what they're doing. They're trying to like discover smaller and smaller particles. At the same time, it seems kind of like simple, but I don't know. I don't know how I feel about that. I know it's like a big like united, like a lot of the countries united and put like funds into it and all that. But it seems kind of weird to me that they're just shooting particles at each other. It's kind of like gas. It's like, I don't know how to explain it necessarily. It seems like the breaking atom, they're trying to break down atoms because of the strong nuclear force is so strong it can't necessarily break them as easily as we think they are. But going to the speed of light and smashing into each other, it's I guess it closes the space. And the strong nuclear force has to give because they're going so fast that the energy has to go somewhere. I get that. But, you know, like enzymes and like breaking down stuff, there might be another way to break down things. And since energy is all about movement, can you transfer the energy in a different way with like vibrations or something to like, I don't know. Yeah, there might be a lot of energy too trying to do that. So I don't know. I think that's the problem. What energy conservation, how much energy you want to use to break an atom. There's like so much potential energy to break something so small, like nuclear fission and nuclear fusion and all that. All right, let me get. All right, y'all probably like talking way too much, but thank y'all for watching. I am A.Ruggamuffin. Check me out. If you want me to watch more of these videos, let me know. And my God.